Assalamualaikum and hi everyone. It's me again, Madam Physics. For today's lesson, we are going to enter a new subtopic in this chapter, which is gravitational potential energy. So here is the learning outcome for today. At the end of this lesson, you should be able to define and use the formula of gravitational potential energy, which is given by U equals to negative gmm over r. This formula somehow look almost the same as the formula of force and gravitational field strength. So make sure you know the difference between them. Before we go any further, let's recap about the gravitational field strength. We know that for a massive spherical body, for example the Earth, the gravitational field lines are equally spaced and directed radially inwards towards the center. You can see that at the surface of the Earth, the gravitational field lines are almost parallel. If we could observe the field lines near the surface of the Earth, we could see that the lines are equally spaced and parallel to each other. It shows that the gravitational field strength is uniform near the surface of the Earth and has constant in magnitude, which is 9.81 meter per second squared. Let's look at the general definition of potential energy. Potential energy is the energy associated with position. For example, a ball that is going up, it will store some potential energy because it has a certain height from the surface of the Earth. To quantify this potential energy, there is a formula that is given by U equals to mgh. U is the symbol of this potential energy and m is the mass of the ball or any object. G is gravitational acceleration or also known as gravitational field strength that is constant near the surface of the Earth, which is 9.81 meter per second squared, and h represent the height or position of the ball. By using this formula, you can figure out the amount of energy stored or the amount of work required to bring any object to a certain height. U equals to mgh can be used to calculate the change of potential energy for an object that has a change in vertical height. However, this formula only valid for an object that is located near the surface of the Earth because we know that g is constant here and has a value of 9.81. What if the ball is brought far away from the surface of the Earth? Is the formula of U equals to mgh still valid for that position? If your answer is yes, are you really sure that at this position, the g is also 9.81? Well, to know the answer, first we need to check the value of g at that position. We know that g is 9.81 near the surface of the Earth. Therefore, for the position that is very far from the Earth, the g should be less than 9.81 because we know that the strength of gravitational field is weaker as the distance of the object is further. Therefore, to calculate the gravitational potential energy at that position, we cannot simply use this formula and assume that G is always 9.81. To know the gravitational field strength or G at this position, we can use the formula of Ag that we learned in previous video. To calculate the gravitational potential energy at that position, we simply substitute the formula of Ag into U equals to mgh. So m times the formula of Ag and times with the height that is equal to r. The equation will then become U equals to gmm over r. This gravitational potential energy will represent the amount of work required to bring the ball to that point. When we look at the relation between U and r, we can see that the higher value of r, the less will be the value of U. This formula somehow contradicts with the theory of U, where it should be increases with r. Therefore, in order to make the formula match with the theory, we can just simply put the negative sign in the formula. So the gravitational potential energy is always negative, and you will see that the further the distance of object from the Earth, the gravitational potential energy will become less negative. It means that the magnitude of U is bigger. What if the object goes to infinity? What will happen to the value of U? From the formula of U equals to negative gmm over r, where big M is the mass of the Earth and small m is the mass of the rocket, when r goes to infinity, the magnitude of u will approach to 0 because we know that 1 over infinity equals to 0. The relation is now makes sense. The further the distance r from the Earth, the higher will be the value of gravitational potential energy because u will become less negative and then u will become 0 as r is infinitely far from the Earth. Let's say if you want to calculate how much work is done to bring the mass from point A to point B. The amount of work done is equivalent to the change of potential energy, which is the difference between final and initial U. So we replace each term with the formula of U and label the R accordingly, where B is the final position and A is the initial position. But don't forget the negative sign of U in the formula. Let us try once again if the object is brought from infinity to point B at a height r from the center of the Earth. To know how much work is done, we will do the same thing as previous case. So change of potential energy, where we minus final and initial potential energy. And for this time, the initial r is infinity because the object comes from infinity. This term will become 0 because we know that any number divided by infinity is equals to 0. We finally come out with the same formula of u that is introduced earlier, which is u equals to negative gmm over r with a negative sign. That is why gravitational potential energy is defined as work done by gravitational force to bring an object from infinity to a certain point. Okay, so in the video earlier, I already explained about the gravitational potential energy in the second subtopic of chapter 7, 7.2. So kita kena tahu macam mana kita nak gunakan formula gravitational potential energy, how to define the gravitational potential energy, sebab kita dalam kita punya learning outcome, kita ada define and then kita kena tahu menggunakan formula. So basically dia punya learning outcome sangat simple. Kita just tahu formula dan kita faham apa definition dia. Then kita kena gunakan formula tu according to the situation given in the question. Okay, so basically apa yang saya dah explain dalam video tadi, dalam animation tadi, saya explain tentang formula U equals to negative GMM over R ni. Datangnya daripada formula, basic formula untuk potential energy, which is U equals to mgh. Okay, kenapa kita tak gunakan mgh sedangkan ini pun potential energy? Okay, so ada reason, ada reason kenapa. Okay, so ada reason kenapa dan saya explain disebabkan oleh G kita dekat sini adalah 9.1. So G equals to 9.81. Okay, adalah gravitational acceleration on the surface of Earth. Okay, so dalam chapter ni kita tak discuss objek yang berada pada surface of the Earth, tak. Okay, so tak discuss semata-mata objek yang berada near the surface of the Earth. So kita discuss objek yang berada jauh daripada Earth. So kita still boleh kira dia punya gravitational potential energy by using this formula. Okay, so tak semestinya nilai G kita tu adalah 9.81 lah. Okay, so ada mistake is 9.81 ms negative 2. Okay, so kalau kita tengok formula U negative GMM over R ni lebih kurang sama dengan dua formula yang kita dah belajar dalam chapter ni. So ada dua kuantiti yang kita dah belajar. Kuantiti pertama kita ada belajar tentang gravitational force, okay, F ataupun kadang-kadang ada juga label SFG equals to GMM over R square. Okay, so bezanya kat sini kalau F dia adalah R square tapi U dia adalah R. And then dia ada negative sign jugalah. Okay, dan yang kedua, formula untuk gravitational field strength which is AG equals to GM over R square. Okay, yang bezanya dengan U dia tak ada small m dekat situ. Okay, so formula AG ni sama juga dengan G yang kita belajar which is equal to 9.1. Tapi usually G kita gunakan apabila dia berada pada surface of the Earth. Tetapi AG ni dia boleh jadi kat mana-mana around the Earth, around any massive spherical body. So kita boleh kira berapa AG kalau dia jauh daripada Earth. Kalau dia terlalu jauh daripada Earth, kita boleh expect nilai G kita, nilai AG kita akan kurang daripada 9.1.
Sebab bila R makin tinggi, kita punya strength of AG becomes weaker. Okay, so kita dah cerita tentang relation dekat situ. Okay, so formula U dan formula yang ketiga adalah formula U lah, gravitational potential energy. Lebih kurang sama. Yang membezakannya adalah yang membezakannya dengan AG sebab dia ada M dan dia ada negatif dekat sini. Okay, so kita highlightkan sikit negatif kat sini. So saya dah explain juga negative sign dalam formula U ni. It's actually just to kita nak macam mana kita nak talikan yang relation antara U dengan R ni always directly proportional. Sebab kita tahu semakin tinggi kedudukan objek daripada surface of Earth, semakin tinggi nilai gravitational potential energy. Okay, so itu yang kita faham. Sebab dia store energy due to the height. Logiknya semakin tinggi height, semakin tinggi nilai U. Tapi disebabkan formula ni tadi kalau tak ada negatif, dia jadi inversely proportional between U and R, okay, dia dah jadi inversely proportional. So kita kena add on negative sign ni, baru kita nampak dia directly proportional lah dekat situ. So bila nilai R makin tinggi, okay, bila nilai R makin tinggi, value dia nanti akan makin kecil. Okay, value yang kita akan kira, value U yang kita akan kira makin kecil. Tapi disebabkan ada negative sign, walaupun makin kecil, contoh negative 10, dengan negatif 1. Okay. So nampak kat sini 1 ni lebih kecil. Tapi end up sebenarnya U ini, kita label U1 dengan U2. Okay. End up kita boleh conclude sebenarnya U2 is greater than U1. Okay. Disebabkan apa? Disebabkan magnitude dia less negative. Okay. So, of course lah negative 1 is greater than negative 10. Okay, so kita nak make sure, negative sign tu just nak make sure relation antara U dengan R tu still valid lah. So, dia still directly proportional. Okay, so formula ini juga, negative GMM over R ini sebenarnya actually dia adalah equal to work done by gravitational force to bring any test mass from infinity to a point. Okay, yang ni pun ada juga saya explain macam mana boleh datangnya formula. Bukan, macam mana boleh formula ini represent work done to bring an object from infinity to a point. So, contoh kita ada Earth. Okay, kita nak bawa sesuatu objek, tak kisahlah apa-apa objek, contoh roket ke dia nak bergerak daripada infinity kepada satu point. Okay, so ini point yang kita nak bawa roket tu. So, daripada infinity kepada satu point. So, dekat sini, jarak daripada Earth, daripada center, so always R is always from the center. R kita adalah infinity. Kemudian at this point daripada center, so kita label as R. Tak kisahlah R apa pun. Okay, so bila kita derive formula change in potential energy, change in potential maksudnya mesti final minus initial kan. So kalau infinity, kalau R kita infinity, of course kita dah tahu U kita mesti jadi kosong. Okay, U kita mesti jadi kosong. Sebab 1 over infinity, sebab R di bawah kan, 1 over infinity, it will become 0. Jadi, end up, apa yang kita akan kata, final dekat sini adalah R lah. Final adalah R. Okay, initial adalah kosong. So, end up kita akan still dapat balik formula asal U. That's why, kita boleh kata, kalau soalan minta, calculate the work done to bring any task mass, to bring this object from infinity to a point, we can just simply use this formula. Gunakan saja formula ni. Kita dah sebenarnya kira dah perubahan energi tu. Work done to bring any object from infinity to a point. Sebab infinity, U kita kosong. So, bila kita sampai dekat point tu, bila objek tu sampai dekat point tu, ini adalah amount of work done. Okay? Which simply use this formula. Okay, so itu adalah penggunaan delta U kat sini. Basic konsep mesti tahu yang dia adalah final minus initial. Itu contoh infinity kepada point kan. Okay, contoh kalau yang ni daripada point to point. Maksudnya R tu kedua-duanya ada value. Daripada point, daripada point 2 kepada point 1. Contoh daripada R2 kepada R1. Jadi logiknya kita akan gunakan basic concept. Kalau kita nak kira work done to bring this test mass from point 2 to point 1. So kita gunakan basic concept lah. Final minus initial. So final akan jadi, siapa final? Yang ni akan jadi final lah. Sebab dia 2 kepada 1 kan. Yang ni akan jadi initial. Jadi by using this formula, okay, satu adalah mass earth, satu adalah test mass, kita kena specifykan R kita ni lah. Okay, so yang mana final, dia akan jadi R2 final. Yang mana initial, R1 akan jadi initial. So just tolakkan nilai yang atas ni sepatutnya akan sama lah. So dia GMM over R. Okay, so basic sangat sebenarnya gravitational potential energy. So kena faham definition tu, work done to bring any object from infinity to a point, we can just simply use the formula of U, negative GMM over R. Tapi kalau soalan tu tanya daripada satu point kepada point yang lain, dua-dua tu ada nilai R, kita kena tolakkan final, tolak initial. And last kali nak highlightkan tentang unit bagi gravitational potential energy. Sepatutnya semua dah tahulah. Okay, so unit dia mestilah joule. Okay, so let's look at example 3. Okay, so a satellite has a mass 100 kg and is located 2 exponent 6 meter above the surface of the Earth. Kita lukis sikit lah. So, kita ada satellite around a surface of the Earth. Okay, ni Earth which 2 exponent 6 meter from ni satellite Okay, kita buat X untuk satellite. Satellite, macam ni je satellite Allah, fail. Okay, satellite 2 exponent 6 meter height from the surface of the Earth. What is the potential energy associated with the satellite at this location? So, dia just minta potential energy, and the formula of potential energy is negative G M over R. Jangan lupa negative sign, okay? And then, senanglah. R kita dah ada. So, basically this is actually R. And then kita ada tak radius of Earth? Okay, it's given. Radius of Earth is given here. So, korang kena tahu R tu mesti measure daripada center. So, 6.38 times 10 to the power of 6 meter. So, maksudnya R kita adalah hasil tambah kedua-dua ni. Ini baru R. Okay, so saya salah tadilah. Saya kata R di bahagian atas kan. So, sebenarnya hasil tambah kedua-dua. Distance ni, kedua-dua height ni sebab dia daripada center. So, simply substitute all the information. Negative 11. G ni dah auto kita ingat lah. Okay, tapi dalam exam dia akan ada dalam list constant. So, tak perlu hafal pun. So, mass, capital M for mass of the Earth, 5.98 times 10 to the power of 24. Small m is the mass of satellite, 100 over. With R, ada 2, 2 exponent 6 plus with 6.38 times 10 to the power of 6. Tak ada square, bukan macam force. Okay, so kirakan dan sepatutnya jawapan kita akan dapat negative sign lah. Okay, dan unit kita mestilah joule. Okay, so basic sahaja. Okay, kalau dia tanya change in potential energy, so kita kena tengok mana-mana point lah, mana-mana point yang dia tengah consider. Daripada point mana kepada point mana, and then kita akan tolakkan final minus initial.
So that's the end of our lesson. Hope to see you again in the next video, and thanks for watching.